California Electrical Code, or SEC, does not require the use of 12-gauge wire in dining rooms and nooks located near kitchens in residential homes. Instead, the CEC typically permits the use of 14-gauge wire for general lighting and receptacle circuits in these areas. However, it's essential to understand that electrical codes can vary based on location. Some local jurisdictions may have specific requirements that differ from the state code. These local amendments can sometimes mandate the use of 12-gauge wire in certain areas, even if the CEC allows for 14-gauge wire. To ensure compliance with all applicable regulations, consulting the local building code is always a good idea. This will provide clarity on any specific requirements in your area regarding wire gauge for dining rooms and nooks. When determining the appropriate wire gauge for electrical circuits, several factors must be considered. Firstly, the ampacity of the wire, which refers to the maximum amount of electrical current a conductor can carry continuously without exceeding its temperature rating, is crucial. Secondly, the National Electrical Code, or NEC, provides tables that specify the allowable ampacities for different wire gauges and insulation types. Thirdly, for example, Table 310.15. V16 in the 2020 NEC lists the ampacities for conductors insulated with types such as THHN, THHW, and XHHW, which are commonly used in residential wiring. 14-gauge copper wire with THHN insulation, for instance, typically has an ampacity of 15 amps, while 12-gauge copper wire with the same insulation type usually has an ampacity of 20 amps. The size of the circuit breaker or fuse protecting the circuit must be coordinated with the wire's ampacity. The overcurrent protection device should not exceed the wire's ampacity to prevent overheating and potential fire hazards. 14-gauge wire is generally suitable for 15-amp circuits, while 12-gauge wire is appropriate for 20-amp circuits. In a typical residential setting, 15-amp circuits are commonly used for general lighting and receptacle outlets in living rooms, bedrooms, and dining rooms. 20-amp circuits are often used in kitchens and laundry rooms to accommodate appliances that draw more power. The NEC specifies requirements for receptacle outlets in dwelling units to ensure convenience and safety. Receptacles in kitchens and dining areas must be installed so that no point along the wall line is more than 6 feet from a receptacle. This requirement ensures that appliances and other electrical devices can be easily connected without the use of extension cords, which can be a safety hazard. The NEC also requires that small appliance branch circuits serve receptacle outlets in kitchens, pantries, breakfast rooms, dining rooms, and similar areas. These circuits must be rated at 20 amps and should serve no other outlets. The purpose of these dedicated circuits is to prevent overloading and ensure that appliances can operate safely without tripping breakers. Ground fault circuit interrupter, or GFCI, protection is required for receptacle outlets in certain locations to protect against electrical shock. GFCI protection is typically required for receptacle outlets in bathrooms, kitchens, garages, and outdoor areas where there is a higher risk of exposure to moisture. GFCI devices monitor the current flowing in a circuit and quickly trip if they detect a ground fault, which is a leakage of current to ground. The installation of electrical wiring must comply with all applicable codes and regulations to ensure safety and prevent electrical hazards. Electrical work should be performed by qualified electricians who are familiar with the NEC and local building codes. Permit requirements vary depending on the type and scope of the electrical work. Some jurisdictions require permits for all electrical work, while others may exempt minor repairs or replacements. It is important to check with the local building department to determine whether a permit is required for a specific project. Electrical inspections are typically required after electrical work has been completed to ensure that it complies with the code. Electrical inspectors will examine the wiring, connections, and grounding to verify that they meet the safety standards. Any deficiencies must be corrected before the inspection is approved. Selecting the correct wire gauge for electrical circuits is essential for safety and performance. Using wire that is too small for the intended load can result in overheating, voltage drop, and potential fire hazards. Overheating can damage the insulation on the wire, leading to short circuits and electrical fires. Voltage drop occurs when the voltage at the end of a circuit is significantly lower than the voltage at the source. This can cause appliances to operate inefficiently and can even damage them. Using wire that is too large for the intended load is generally not a safety issue, but it can be more expensive and may be difficult to work with. The NEC provides guidelines for calculating the appropriate wire size based on the load, distance, and voltage drop. These calculations take into account the ampacity of the wire, the length of the circuit, and the voltage drop allowed. Proper grounding is crucial for electrical safety. Grounding provides a path for fault current to flow back to the source, which trips the circuit breaker or fuse and energizes the circuit. This helps to prevent electrical shock and equipment damage. The NEC specifies requirements for grounding electrodes, grounding conductors, and bonding to ensure that electrical systems are properly grounded. Grounding electrodes are typically metal rods, pipes, or plates that are buried in the ground. Grounding conductors connect the grounding electrodes to the electrical system. Bonding is the process of connecting metal parts of the electrical system together to create a low impedance path for fault current. The NEC also includes requirements for arc fault circuit interrupters, or size, to protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. A size detects arc faults and quickly trip the circuit breaker to de-energize the circuit. SIs are typically required for branch circuits that supply receptacle outlets in bedrooms, living rooms, dining rooms, and other areas where there is a higher risk of arc faults. Electrical safety is paramount, and it is important to take precautions to prevent electrical accidents. Firstly, always turn off the power before working on electrical circuits. Secondly, use insulated tools and equipment. Thirdly, never work on electrical circuits when you are wet or standing in water. Fourthly, inspect electrical cords and plugs regularly for damage. Fifthly, replace damaged cords and plugs immediately. Sixthly, do not overload electrical circuits. Seventhly, use extension cords sparingly and only for temporary purposes. Eighthly, install ground fault circuit interrupters, or GFCIs, in areas where there is a risk of exposure to moisture. Ninthly, install arc fault circuit interrupters, or size, to protect against arc faults. Tenthly, have your electrical system inspected regularly by a qualified electrician. When planning electrical work, it is important to consider the future needs of the space. Adding extra circuits and outlets during construction or renovation can save time and money in the long run. Consider the placement of furniture and appliances when determining the location of receptacle outlets. Install dedicated circuits for appliances that draw a lot of power, such as refrigerators, microwaves, and air conditioners. Plan for future expansion by installing conduit or empty raceways that can be used to run additional wires later. Smart home technology is becoming increasingly popular, and it is important to plan for the integration of smart devices into the electrical system. Smart home devices often require dedicated circuits and network connections. Consider installing smart switches, outlets, and lighting controls to enhance the convenience and energy efficiency of your home. The NEC is updated every 3 years to reflect changes in technology and best practices. Staying up to date with the latest code requirements is essential for electrical professionals. The NEC is a complex document, and it is important to consult with qualified electricians and engineers to ensure compliance. Numerous resources are available to help people understand and comply with the NEC. These resources include training courses, publications, and online forums. The National Fire Protection Association, or NFPA, publishes the NEC and offers a variety of training and certification programs for electrical professionals. Understanding the electrical code requirements for dining rooms and nooks near the kitchen is crucial for ensuring the safety and functionality of these spaces. While the California Electrical Code typically allows for 14-gauge wire for general lighting and receptacle circuits, it is essential to verify local building codes for any specific requirements that may mandate the use of 12-gauge wire. By following the appropriate wiring practices and adhering to all applicable codes and regulations, you can create a safe and efficient electrical system for your home. If you are unsure about any aspect of electrical wiring, it is always best to consult with a qualified electrician. They can assess your specific needs, provide expert advice, and ensure that all work is performed safely and in compliance with the code. Remember that electricity can be dangerous, and it is always better to err on the side of caution.